everyone, I'm Dr. Bernice Kwong from the University of Southampton, and this third video will show an example of how to do a competing risks event history analysis using the Harmonized Histories dataset. You can watch video 1 in this series to get a quick introduction to what the Harmonized Histories are, what kinds of data they contain, and how to access them. And then you can watch video 2 in this series to see an example of how to do an event history analysis when there's only one event of interest. So due to privacy and data security, I can't post any of the data that, any of the actual Harmonized Histories data. You have to apply to use it and download it yourself for your own research. But I have instead posted as worked out examples all of the code that I've used in all of the videos. So you might want to do a competing risks analysis if there's an event you're interested in, but it cannot happen if another event happens first. For example, if you're interested in looking at people who live together and their pathway towards getting married, the other event that could happen instead is breaking up. So a couple who live together or cohabit, they can't get married if they break up first. So that risk of a breakup competes with the risk of marriage, and then one of these events has got to happen first. So like a survival analysis that only has one event of interest, we first need to figure out when someone first becomes at risk of experiencing either of these competing events. So for marriage, you're theoretically at risk of marrying as soon as your partnership begins. You're also, a bit depressingly, at risk of breaking up as soon as your partnership begins. Then after that, you need to determine when you're not at risk for the event anymore, which will be either after the event happens or if your partner dies or when the observation period ends. So like we would do with an analysis that only has one event of interest, we first create a variable describing the analysis time for each subject, and we will call this variable duration because it's the duration that you last in this risk set. So it's the time elapsed or duration from time at entry into the risk set to the event time or censoring time. And remember, censoring time is the end of the risk period when you haven't experienced an event. So an event time is when the event happens. The censoring time is the end of the observation period, but an event has not happened. So then you have this duration variable and you expand it into one row per unit of time. For example, someone who has 3 years of analysis time, so that means they either experience the event in 3 years or they were observed for 3 years, they will, when you expand this duration variable, you'll end up with 3 rows of data with one row representing each year for that person. So this reshapes the data set into a person period file, and then you find the person year where the event occurred, and then you label it. So here's an example of what that would look like. Each row in the data set at the top represents one person. And the command to open it up into a long person period or person time file is expand. The command is expand, and then duration is the variable. So we've calculated duration here based on when the event, marriage or separation, happens with respect to when the time at risk happens. So the time at risk is when Union 1, the year Union 1 was formed. And then your event will be either when you marry or when you separate. And then you calculate, so for this respondent 2 here, 2002 minus 2, their duration is 2. For respondent 1, 1995 minus 1990, their duration is 5. For respondent 3, they don't have either event, right? But they're observed until the day they report that their entire partnership history. So 2022 minus 2016 is 6. So that's their duration. So when you expand by duration, it changes the data set to look like this at the bottom, where respondent 1 now has 5 rows of data, 1 for each year. Respondent 2 has 2 rows, 1 for each year, and respondent 3 has 6 rows. So each row in this data set now represents 1 year in one specific respondent's life. After that, you label each person year to describe what the time is with respect to the time of origin. So here's an example, again, with the same 3 different respondents, and they each have different durations, right? So respondent 1's duration of analysis is 5 years, so they have 5 rows, and each row is they're not all the same year, right? They're not all describing year 5. Row 1 is describing year 1, row 2 describes year 2, and then you tick up to year 3, 4, and 5. Respondent 2's got 2 years, so they start with year 1, and then they end with year 2. And then respondent 3 has got 6 years, so they tick up 1, 2, 3, 4, 5, 6, all the way to the end of their analysis period. So we've done this by sorting the list, the person period file, by respondent. So you group all of their, like respondent 1's time is all here, and then you create for, their time variable, the number of rows they have, which is _n. And they have the same number of rows that corresponds to their duration because of the expand duration command we use on the previous slide. So the variable time, it ticks up 1 year at a time like a clock. So then you flag the person year that the event occurred in. And this year should be the person time that's the final year in the duration from partnership entry till the end of analysis time. So here's the code to do that. So you figure out what the outcome is, and you label the outcome with the state when the time is the same as when the time, like when year 1 and duration are the same. So in the 5th year, something happens. So when it's ticked up to year 5, then this is the row that has the event. So when it's marriage, partnership 1 ended in a marriage, and then we label that row marriage. When it's separation, partnership 1 has ended in a separation that occurred before marriage. So we label that row separation. So it's a little hard to think in your head, but if you look at it, this is what it should look like. So that command makes the data look like this. So we have a Y or outcome variable that describes the state or partnership status that the respondent is in that particular year. So respondent 1, who begins their relationship in 1990, marries in 1995. They've got 5 years, right? But the first 4 years, they were not married. The first 4 years, they were cohabiting. So they cohabit, and they marry in that 5th year, that year when the time variable is equal to duration. And that's how we generated that flag, right? When time equals duration, flag that year married. So for respondent 2, they entered their relationship in the year 2000, and they separated in 2002. So they have 2 years of duration, 2 years of analysis time. They've been followed, they were at risk for an event for 2 years. Year 1, they're cohabiting. Year 2, they were separated because time in that row is 2 and duration is 2. So what about people who don't experience an event? Well, these people should only have cohabiting as their state because their state never changes, right? So they're always in the state of cohabitation because they never have an event. So meaning in year 1, they're cohabitors. In year 2, they're cohabiting. In year 3, they're cohabiting, and so on until the analysis time runs out, which for the case of respondent 3, who's followed up for 6 years, it's on the 6th year. So that's the time of the survey, which is for all of these respondents, 2022. So respondent 3 is in a relatively new relationship compared to their peers who, entered their relationships in 2000 and 1990. These relationships are, they began a lot longer ago. So this person entered their relationship in 2016, or their co-residential partnership, I should say, in 2016. And then in 2022, they reported, that they're reporting their partnership history. So they've had 6 years of follow-up time, essentially, so that all of their states are cohabiting throughout, because they never experience the event. So for the harmonized histories, just remember, people can only be followed up until the year of their interview, since people report their partnerships retrospectively. So, we can only know information that happened to them up until the day they tell us. They can't tell us what happens to them in the future. Okay, so how do you do a regression analysis using the competing risks framework? So you use a multinomial logistic regression and set the outcome to be Y, which has 3 categories in this case: marriage, separation, and remaining in cohabitation. So remember the outcome, because this is about the history and the like the timing of things. The outcome is not just what the partnership status is. It's not just about what happens, but it's also about when things happen. So the outcome is not just like one status or one change in partnership status. It's about the change in partnership status at a certain time. So the analytical unit is not one person, but one person year. So think about each analytical unit is a row, which is what a person year is, right? So we've set up the mlogit the way you would any other mlogit. So, use the command mlogit. Y is the outcome, and then here are all the covariates. You have to include time because remember, this is all about how long does it take for things to happen? What are the hazards of something happening, given that it hasn't happened yet? So include time as one of your covariates because it tells you the duration at which somebody lasts till. And then we've used two very, basic background variables that are standard in partnership analysis: education in 3 categories, so low, medium, high, with high as your reference category, and the start age of the relationship. So when the person entered into the relationship, what age were they? And that's been set up as a continuous variable. So 3 possible outcomes: marriage, separation, remaining, and cohabitation. Remaining and cohabitation is the baseline outcome. Marriage is one event, separation is another event. So this output here on the right shows the relationship between the odds of the outcome, marriage or separation, and the covariates, education and start age. So we see that starting the relationship at an older age increases the odds of marriage. We just look at marriage in reference to cohabitation. So that start age, the odds ratio is over 1, and it's significant. So it's 1.027 to 1, which means for each year older you are when you enter a relationship, your odds of marriage increase by 2.7%. So this is 1.27, right? So compared to for an odds ratio, it's a 2.7% increase for each additional year older you are. And that kind of makes sense. Relationships formed at a later age do tend to be more marriage oriented. Culturally, that completely makes sense. And then here we say that being less educated decreases the odds of marriage, which is also tends to be the social pattern of marriage. So if you're medium educated compared to high educated, then you have a approximately 20% lower odds or lower likelihood of being married compared to the highly educated. And if you're low educated, you have an even lower likelihood. So the odds ratio is 1 to 0.56. So there's a quick run through of how to do a competing risks analysis using Stata and the event history, or the harmonized histories. So we've talked about how to set up the data and how to open it up, how it should look, and then finally how to apply multinomial logistic regression to the data set. So hopefully that was helpful, and I hope you all use the harmonized histories for your fertility and partnership and life course analyses. Thank you so much for your attention.